This is Algebra 2, Lesson 12-1. Adding and subtracting matrices. Corresponding elements are elements in the same position in each matrix. Meaning, if I have a matrix, and let's say I have a matrix like this, which is 1, 2, 4, 6, and I have another matrix over here, which is 0, 3, 4, 9. The corresponding elements are like the 2 in the matrix on the left corresponds to the 3 on the matrix on the right, because it is in the same position. It's in the the first row of the second column. A matrix equation is an equation in which the variable is a matrix. A zero matrix is an additive identity matrix of the set of all m times n matrices. All elements are zeros, which means that a zero matrix basically means this. I have a matrix no matter what size it is, and all the elements are zeros. That's a zero matrix, whether it's a 2 by 2 matrix, a 3 by 3 matrix, a 4 by 6 matrix, whatever. Equal matrices are matrices with the same dimensions and equal corresponding elements. An equal matrix would be something like 1, 2, 3, 4 would be an equal matrix to 1, 2, 3, 4. They're both the same size, and they all have corresponding elements that are equal. Okay? Sometimes you want to combine matrices to get new information. You can combine two matrices with equal dimensions by adding or subtracting the corresponding elements. And this is not a difficult concept. Let's take a look at these two matrices right here. If we were going to add or subtract these matrices in order to, excuse me, to do whatever they ask us to do. In order to add or subtract a matrix, they have to have the same number of rows and the same number of columns. Okay? Remember, rows go across and columns go down. The easiest way to remember that, columns hold up buildings. They're like little posts that hold up buildings. So, since this particular matrix A is got 3 rows and 2 columns, and matrix B also has 3 rows and 2 columns, they can be added or subtracted because they are the same size. We would name this a 3 by 2 matrix, and this one a 3 by 2 matrix. Same size, therefore they can be combined. If I was going to combine A and B, I would simply combine the corresponding elements. For example, I would have -9 plus -7, -3 plus -2, 9 plus 4, 0 plus 6, 4 plus 9, and 3 plus -3. All I did was equate the corresponding elements. This -9 went with that -7, this -3 went with that -2, and they went in their corresponding places. And now, of course, I'll do the math. So to finish this matrix, -9 and -7 is -16. So this will be -16, -5. 9 and 4 is 13, 0 and 6 is 6, 4 and 9 is 13, and 3 and -3 is 0. So here's my end result when I add those two matrices together. I still get a 3 by 2 matrix. Still has to be the same size. If I'm going to subtract, we just use the same rules, the properties of subtraction, but remember here order matters, so it has to be B minus A. So I'm going to do -7 minus a -9, and then I'm going to have -2 minus a -3, and that would be then equal 4 minus 9, 6 minus 0, 9 minus 4, and then -3 minus 3. So there's my middle matrix. Now when I add and subtract those properly, -9 minus 2, -7 minus -9 means -7 plus 9, which is going to be 2. So this would be 2 and 1. And this would be -5 and 6. And my last row will be 5 and -6. And that is my matrix when I am finished subtracting it. Just subtract the corresponding elements. Always good to keep track of what you're doing. You can use the addition and subtraction properties of equality to solve a matrix equation as well. Let's take a look at this. It says the tables show the numbers of hours 2 students spent on homework in math and science, which student spent more hours on homework in the spring? Okay, so we have two tables. We have one with the fall semester hours, and we have one with both the fall and, this one's just fall, this one is fall and spring. So in order to figure out who spent the most hours in the spring, we have to take the spring and subtract it from the fall. That's the easiest way to do that. So we'll look at this. We have student A. Student A, if you look at student A, you have 300 minus 166 for math, and you have 227 minus 133 for science. And for student B, we have 282 minus 140 for math, and we have 231 minus 120 for science. So when you work this little matrix out right here, if I take 300 minus 166 from it, I'll get 134. If I take 227 and subtract 133, I'll get 94. If I subtract 140 from 282, I get 142. And if I take 231 and subtract 120, I get 111. So by looking at this matrix, now this matrix here would just be the spring hours. So if we look at this, which students spent more time hours studying on homework in the spring, you can clearly see that student B spent more time on homework in the spring. So the answer here would be student B. Now, some of the properties of real number addition apply also to matrix addition. And I'm going to go through these very quickly because they're not all that complicated. If A plus B is an M times N matrix, that's just a closure property. Just means that if it is, it is. Okay? If A plus B has to equal B plus A, commutative property. When you're adding matrices, the same as adding numbers, order doesn't matter. The associative property also applies. You can do A plus B first and then add C, or you can do B plus C first and then add A. Okay? We have the additive identity, which basically means there exists a unique matrix M times M by N, such that the O matrix times the original matrix gives you the original matrix. Basically means you're adding a 0 to everything. And for each matrix, there exists a unique opposite, and the matrix plus its opposite is 0, which is the additive inverse property. And then, of course, for matrix subtraction, if two matrices A and B have the same dimensions, then A minus B equals A plus A minus B. Same thing, matrix subtraction. All of these are rules that we've applied to many other things before this, just proving that they also apply to matrices. Okay, finding an unknown matrix value. To solve a matrix equation, you use the addition and subtraction properties of the quality, just like solving an equation would do. So if I have x minus the matrix 2, 5, 3, negative 1, 8, 0 equals 10, negative 3, negative 4, 9, 6, negative 9, to solve this, I would have to add, because this is a subtraction sign right here, I would have to add this matrix to this side of the equation. So I'm going to do that. Okay? X would equal 10, negative 3, negative 4, 9, 6, negative 9. That's the original matrix that's on the right side of the equal sign. And we're going to take that and we're going to add the matrix 2, 5, 3, negative 1, 8, 0. And when we add those together, we'll get the answer for x. Okay, so x is going to equal 10 plus 2 is 12, negative 3 plus 5 is 2, negative 4 plus 3 is negative 1, 9 plus negative 1 is 8, 6 plus 8 is 14, and negative 9 plus 0 is negative 9. So there we have it. And I skipped the middle step here just because I figured that at this point in time you can figure out how to do that. You can show that middle step if you like. Right here you could say 10 plus 2, negative 3 plus 5, negative 4 plus 3, 9 minus 1, 6 plus 8, and then negative 1 plus 1. And we will go back. It's very simple to do. To solve for unknown elements, if the matrices are equal, then the corresponding elements must also be equal. So, if I have 2m minus n in this position right here, first row, first column, it has to be equal to first row, first column here because there is an equal sign between them. So I can just set that up. I can say 2m minus n has to equal 15. Okay. And then I will look at this next one, negative 3 and the m plus n, which means negative 3 has to equal m plus n. If I look at my next corresponding thing here, 8 equals 8, I don't have to do anything with that because 8 does equal 8. There's no variable to solve for, so I can just leave that out. And last but not least, I can look at my last section, which would be right here, and I would have negative 4m plus 2n equals 30. Oops, negative 30. I almost forgot my negatives. All right, now I have 3 equations, right? Which means I can solve them for any one variable. It's probably easier if I would list them one on top of each other. So I have 2m minus n equals 15. I will call that equation 1. Equation 2 I will call m plus n equals negative 3. And equation 3 I will call negative 4m plus 2n equals negative 30. So there I have my 3 equations. I can choose which variable I'm going to eliminate. And it looks very nicely like if I took 1 and 2 and just added them together just the way they were, that n would go bye-bye. So I have 2m plus n equals 15 for equation 1. In equation 2, I have m plus n. Oops, and minus. This first one is subtraction sign. I got to make sure I do that right. It's 2m minus n. I knew I got rid of my n somehow. And this equals negative 3. So if I add those together, I get 3m equals 12. Okay. So divide by 3, m has to equal 4. So now that I know that m equals 4, all I have to do is solve for n. To solve for n, I can go back into any one of the equations. I think equation 2 is probably the easiest one to go into. So m is 4 plus n has to equal negative 3. So if I subtract 4, n has to equal negative 7. So there we have it. I have solved this equation for my 2 missing variables. M is 4 and n is negative 7. And this is basically adding and subtracting of matrices.